So here's the units of the variable resource, and then I'm going to get the total product in. Total amount of the good that we make. There we go. Now let's go through and calculate some of the stuff that we have talked about from the production perspective. Units of the variable resource, think of this as the amount of labor, how many people we hire. And this is the total amount of the good that we produce. So we hire nobody, get nothing. We hire one more person, an additional person from 0 to 1. Now we start making 10 units of the good. Now, as we move from 0 to 1, what's the marginal product? By hiring an additional person, the change in our total product moves from 0 to 10. So that's 10. So you calculate marginal product.
So is that one basically yourself? Is that one basically yourself? Or is that not including yourself?
Oh, it doesn't really matter. Just think of it as labor generally.
Okay.
What about when we move from 1 to 2?
15.
Yeah, everybody sees what we're doing to get the marginal product, the change in total product. Hiring each additional person, what's the change in your output? Yes.
Sorry, I'm a little confused. We're just taking the difference of the total product. We're not doing the change, TP divided by.
It's the same thing.
Okay.
Do you see a difference? So ask your question in its entirety.
So 10 minus. So wouldn't it be like 50 divided by 2?
Where? Here?
Oh, yeah.
So move from 0 to 1,
Okay.
1 to 2. You get it?
Okay.
I see your question because I kind of thought that same thing.
Yeah.
So we're moving between each unit. Yeah? So the unit of the variable resource, for convenience here, it happens to be 1. But if it was more than 1, then you would be dividing by the necessary. So we're still using this formula. It just happens that the change in the variable resource happens to be 1, 1, 1, 1, 1, 1, 1. Yeah? So we're still doing that. Okay? How do we calculate average product? What was the formula we had there?
TP divided by number of units of variable.
Take the total product and divide by the units of the variable resource. So you remember when you study. TP divided by the units of the variable resource. So we hire 0 amount of people. What's the average product?
0.
Remember, you can't divide by 0. One person, what's the productivity or the average product? 2? How much?
12.5.
Everybody sees what I'm doing here to get these numbers? So the average product, we're just taking the total product and we're dividing by the units of the variable resource. So 10 divided by 1, 25 divided by 2. Yes? That's the average product. So this is kind of our production story. Remember, patterns in production determines patterns in cost. So here's the production story. And a lot of what we're going to be doing, when I say pattern, we're going to be looking at the graphs. So I kind of want to sketch out what production looks like graphically. So let's do that. Let's graph this out. Draw your graphs the way I have them. Please make sure you stack them one on top of the other. And up here, I'm going to put the total product. And here, I'm going to put the average product and the marginal product. We're just kind of going to sketch out the graphs. Now, total product, if we sketch it out, looks something like this. Now, a couple of things. With the total product, where it is at the peak, the maximum, kind of estimate that and bring it down for me. We're going to get average product and marginal product here. So a couple of things. When you draw this, a couple of things I want you to be aware of. Your graph needs to look this way, and I'll explain why. Where total product is at the maximum point, I need the marginal product to be moving from positive to negative. So that's the first thing. So where this is at the max, make sure this marginal product is crossing this horizontal axis. The other thing I want you to make sure on your graph is make the marginal product cut the average product, that's why I have an X here, at its highest point, in its peak. So two things. Crosses here, where that is at the max, and the LP needs to cut the AP at its maximum point, and I'll explain why. Because these are relationships that have to hold. These are production relationships where that will always be the case, and I'll explain why. Let me explain the first one. TP being at its maximum point, MP is moving from positive to negative. Marginal product is the change in your total product. Which means, when we have total product increasing and then declining, that's what a maximum is. You're going up and then you start to go down. It necessarily means the change is moving from a positive to a negative number. So where total product was increasing and then it starts to decline, then that means the change used to be positive and now it's negative. Which means right where this thing is at its maximum, this marginal product is 0. It starts off, it's increasing, then it's declining. This was positive. Once it starts to decline, it becomes negative. So mathematically, this has to hold. Total product is at the maximum, NP will be 0, crossing that horizontal axis. That is a truth that will have to be the case. Okay? NP is the change, it used to go up, now it's going down. Then the change used to be positive and now it's negative. That makes sense. Here's the other relationship. Marginal product needs to cut the average product at its highest point. And this too is something that mathematically has to hold. Here's the idea. If you have an array of numbers, and you take the change in those numbers, and the average of that number, or the average of that array rather, the place where they're going to meet is going to be the maximum of the average. Let me explain. Let me give you an example. Let's say we're in this class, and I tell everybody to write their weight on a piece of paper. Don't worry, I'm not gonna have you do that. You look at me like, what? No. So let's say I say, everybody write your weight on a piece of paper and I'm gonna take the average weight in the class. Let's say I do that. And I'm gonna be very generous. I'm gonna say the average weight is 100 pounds. So we take the average weight in the class and it's 100 pounds. Everybody put it up, we take the weight, 100 pounds. Let's say we're here and I hear a knock on the door. And when I open the door, let's say I have a new student. Don't worry that it's the middle of the semester. Ignore all of that, but I have a new student. And let's say this new student, remember I took the average, it's 100 pounds. Let's say this new student, let's say he plays football for Pierce. He's one of the blockers or whatever they call him, offensive, blah, blah, blah. So he's a big guy, right? Let's say he weighs 300 pounds. This new student comes into the class. Remember the average was 100. When this football player enters the class and I retake the average, will the average weight go up or will it go down? It's gonna go up. Whenever you have a change in a number and it's higher than the average, it's gonna pull the average up. Let's say he sits here for a while and he goes, oh crap, I shouldn't be in econ, I hate econ, and he leaves. Which means we're back to the 100 pounds. Let's say I hear another knock on the door, and when I look, I have another student, remember the football player leave, and this student, let's say he's a jockey, not the disc jockey that does the record, but the ones that ride horses. The marginal sits below the average, it will pull it down. It necessarily means the only spot these two things will meet will be the maximum of the average. Every time it's sitting above it, it pulls it up. Every time it's sitting below it, it pulls it down. The only spot they can meet is going to be the maximum of the average. So mathematically, that has to happen. Whenever TP is at its maximum point, MP is moving from positive to negative or it's 0. Marginal product will cut average product at its highest point. Every time we have a change that's higher than the average, it pulls up the average. Every time we have a change that's lower than the average, it pulls it down. So the only spot they'll meet will be the maximum of the average. So when we talk about these relationships with production, remember they're going to define certain things about cost for us in a minute.